Hello everyone, welcome to the explanation. So today we are going to solve a very important problem from the DBMS playlist. So the topic is conversion. So the topic is conversion of ER diagram to table, or we can say conversion of ER diagram to relational schema. Okay, so it is basically, we learned in last videos, we learned about how to draw ER diagram. Okay, so basically there were entities, yes, there were entities, there were relations, we learned about this. So next what we are going to do is we are going to convert this ER diagram in the form of relation, that is table form. Okay, so this is one of the most important questions that is asked in all your exams. So before learning how to convert this complete ER diagram in the form of a relation, we should learn about small properties or small formulation, like how to convert a simple entity, a weak entity, a multi-value attribute. So all these will be covering first, and only after that, at the end of this tutorial, I'll be solving a question. So this tutorial is going to be a bit lengthy. Please have patience and let's start the rules. Okay, so first one is mapping entities to tables. First rule is mapping entities to table. Okay, so for example, if you have an entity student, so it was like this, student, and it had some attributes like its ID, its name, and its age. So how to convert this in table? So the tabular form of this entity will be, it will be a table which will contain three columns, that is ID, name, and age, and the name of this table will be student table. If you are going to denote this ID as a primary key, that is underlining it, so we can denote that this column is the primary key for this table. Okay, so this was simple conversion of entity to a table. Now let's convert, the next one is, we can say mapping entity set with simple attribute. Okay, simple attribute means the above table represents this only. This is a conversion of a entity with simple attributes to a table. Even this table can be written in the form of relation as student, the name of table, small bracket, ID, name, comma, age. Okay, so even, and underline this, so even this is also the form of a relation. So in later videos, while solving the question, either you draw a table or you write this, both of them is known as relation. Okay, so this is the second. Now let's go to the third rule. So all these notes you can find in my site. Please visit my site, you can get all the notes of this. Third number is mapping entity set with composite attribute. Okay, so what happens if the attributes are composite into table? Okay, so what are the composite attributes? Composite attributes means attributes having the multiple, which can be broken into multiple attributes. For example, if we have a entity name as student, so this ID is a simple attribute, whereas this name, it is a composite attribute. Composite attribute means it can be again broken into first name and last name. Okay, so how do we represent this? How do we represent this in the form of table? Simply we are going to draw the table which has the attribute as ID, which has the attribute as first name, and which has the attribute as last name. Okay, so this is the conversion of this type of composite attributes into a form of a table. Okay, so fourth number is mapping entity set with multi-value attribute. Okay, so why I am teaching this, because directly if you solve the question it's going to be hard for you. If I teach you all this small conversion, at the end we are going to draw a big ER diagram and convert it in the relation form. Okay, so entity set with multi-value attribute. Okay, so what is a multi-value attribute? What is a multi-value attribute? Multi-value attributes means a attribute that can have multiple values. Okay, so for example, if you have a student entity, so if this is a simple attribute, so this can be a multi-value attribute. Okay, this can be a multi-value attribute because this phone can be multiple value. Similarly, we have another attribute known as city. So how to represent this, how to draw this in the form of table? So in this case, if we have a multi-value attribute, we are going to break the table into two tables. That is, one table will contain the ID and city, and other table will contain the ID and phone number. Okay, so we have got this ID as the primary key, and one of the table it contains the ID as a foreign key. That is, it is used to represent the foreign key of the table. Okay, so for example, if you have these two tables, this ID can act as a foreign key for this table, phone number table. Okay, next one is fifth number, which is mapping the weak entity into table. So what is a weak entity? A weak entity is an entity which depends on the strong entity for its existence. For example, if you have not watched the videos with what is weak entity and a strong entity, please go back and watch the videos first. So for example, if you have two tables, for example, the one is order table and the other is order item table. Okay, so this order table, it contains multiple order item. So if we have order table, this order item will exist, but if the order table itself doesn't exist, this order item will not exist. So this is called a weak entity. Okay, this is called a weak entity and this is called a strong entity. So how do you draw a table for this weak entity and a strong entity? Okay, so here while drawing the table, we are going to draw two tables. One table is for order table, which will contain some IDs, for example, order ID and order date, and another table is order item table, which is a weak entity. Okay, so it has contained its own ID which act as a primary key, but it also contains this order ID which is the foreign key for this table. Okay, because it is a weak entity, it depends on this table, so its primary key will act as a foreign key in this table. And in this table, the other name can be product name, product quantity, other attributes. Okay, so remember, whenever there is a weak entity and a strong entity, a weak entity always depends on strong entity, and for dependence, its primary key will become the foreign key of this weak entity. Okay, now next one is, how do we represent a relationship? How do we represent a relationship in the form of a table? Okay, so let me draw a diagram first and then we'll explain. Okay, so let us draw a diagram including the relation. Fine, so let us assume that this is a entity employee which contains the attributes such as employee ID, employee name. Let me just take two names here, and here is another entity which is department. So it contains its own IDs, attributes like department name and department ID. Okay, now here the relation is, suppose the relation is works in, it means that the employee works in a department. So if you want to represent this whole diagram in the form of table, we are going to draw three tables here. One table is for employee, which will contain attributes such as EID and ENAME. Okay, only two attributes are there. We are going to have a second table which is known as department table. It will have the attributes such as department ID and department name. Now finally, we are going to have another table which is known as works in table, which is the relationship, and it will have the attribute that is EID from this table and DID from this table. Okay, so this is how we are going to relate this in the form of arrow. So this arrow and this arrow becomes a foreign key for this table. So for this table it is a primary key, for this table it is a primary key, but for this table it acts as the foreign key. Okay, now the question can be then how it represents the relationship like one to one, one to many, or many to one. Okay, so there are certain rules for these three relations. So I think after completing this relation part, we are going to solve the question. So the first part is if there is a one to one relation, what is the formula, what is the rule for this? So for example, if we have an entity P and if we have an entity Q which contains a relation R which is in the form of 1 to 1, okay, and this contains some attributes like P1 and P2, and this contains some attribute like Q1 and Q2. Here it is a primary key, here it is a primary key. So what is the how we are going to represent this in the form of table? Okay, so now I'm not going to draw the table, I'm just going to write the table in the form of schema, that is in the form of relation. Okay, so how we are going to represent this? So in this case, if the relation is 1 to 1, you can either write this relation and this table in a combined form which contains P1, P2 and one attribute from here Q1 which act as a foreign key. This act as a primary key, and the next table we will draw on as Q table, which consists of Q1 and Q2. Let this be a small q, small q, small p, small. Okay, so finally for this type of one-to-one relationship we are going to have two tables in which the first table combined with relation will be a one table and the other table is the Q table. Or if it is a one-to-one relationship, you can also write it as like this: P1 P2, it is the primary key, it is the primary key for this, and you can combine the relationship with Q. Okay, so it will become as, you can either combine this relationship with Q, so it will be written as Q1, Q2 and P1. Okay, so Q1 is the primary key of this table, Q2 is the key, and P1 is the foreign key of this table. Okay, so always remember, if there is a relationship representation, there will always be a foreign key. Foreign key is used to join two tables in the form of a relation. So this is the case of one-to-one relation. So in one-to-one relation, remember, you can combine this relation either with this table or with this table. Okay, so let's go to the next, that is one-to-many relation. Okay, one to many relation. Second case is one to many. Okay, so how am I going to draw this? So for example, let me take the above example only. So there is a P which is combined by relation R to entity Q, and the relation is 1 to n. So if it contains attribute P1 which is a primary key, another attribute P2, it consists of attribute Q1 which is a primary key, another attribute Q2. So how will this be written in the form of a schema or in relation? So here again there will be two tables drawn. First table is QP table, which contains P1 and P2 as the attribute where it is a primary key, and another one is QR table. Remember, which side we have M, we are going to combine the relationship to that table. So Q and R is combined and it forms another table which is Q1, Q2, and of course it contains the foreign key. So this is the primary key and this is the foreign key. Okay, so next, third one we have got one to many. I hope I have completed this. Yeah, next one is many to one. Okay, so can you tell me? I'll just going to change here only. So if it is a many to one relationship, so can you tell me what will be the answer? Yes, the answer will be, it will form a PR table with P1, P2 and a Q1 which act as a foreign key, and there will be only a Q table with Q1 and Q2. Okay, so this is a many to one relationship. Okay, so let me take one example for this. For example, if one department has many professors, but each professor it belongs to only one department. Yes, so it can form a many to one relationship. Yeah, so here the table, suppose we have two tables, two relation, department and professor. So here the relation will be department ID, department will contain department ID and department name, whereas the professor will contain professor ID, professor name, professor age and department ID as a foreign key. Okay, so what is the relation? The relation is one department has many professors, but each professor it belongs to only one department. Okay, so the next one, last one is many to many relationship. Last one is many to many relationship. So how we represent this many to many relationship? So many to many relationship, for example, again we have an entity P and an entity Q, and it is related by a relation R. Here the attributes are P1 and P2, Q1 and Q2. It is a primary key, it is a primary key, and the relation is in the form of M to N. So if you are going to draw a relation or a table for this, it will contain three tables, that is P table having the attribute P1 and P2, Q table having the attributes Q1 and Q2, and R table, it has the attribute P1 as a foreign key and Q1 as a foreign key. So remember, there can be MCQ question from this. If there is a one-to-one relationship, we are going to have two tables. The relation can be with first table or can be with second table. If we are going to have 1 to M relation, it will again have two table, but the relation will always be with the second table. If we have a many to one relation, it is going to have two table, but the relation will be always with the first table. And if we have a many to many relation, it will have three tables. Okay, so I think that's all for the relationship. Now one last topic before going to the question part is about mapping of specialization or generalization. How we map a specialization or generalization. Okay, so let me write here, specialization or generalization. Okay, so what is specialization or generalization? I have already covered. So specialization or generalization means, for example, if we have got a employee entity, so here employee is it can be a teacher is an employee, or a staff is an employee, or a HOD is an employee. So this is called the case of generalization. Okay, so how we represent this in the form of table? So here we'll draw three tables. First one is employee table, which will have attributes, suppose EID, suppose ename and age. This is an employee table. Okay, here it will have another table which is a teacher table. A teacher table which will again have EID and T name. See, now again it will have a staff table. It will have attribute as EID and S name, staff name. Okay, similarly for HOD we will have EID and H name. So you can see that in this generalization case here, the EID is common for all these cases. That is, if in the employee table we have an employee ID, same employee ID will be with the teacher, it will be with the staff, and it will be with the HOD. So we can connect it like this. Okay, fine. So that was about all the rules. Now let me write all the rules before solving the question. First rule is the entity becomes table. Second rule is attributes become column. Third rule is primary key remain as primary keys. Fourth is foreign key are added to represent the relationship. Okay, so relationship, it is represented by a foreign key. Fifth one is, as I wrote in the previous part, that is one-to-one relationship. We have got, okay, we have got two tables and it is been implemented by foreign key in either side. One-to-many relation, we have got two table and the foreign key is implemented in the many side. Many to one, we have two tables and the foreign key is implemented in this many side, and many to many we are going to create a new table itself for the relationship. Okay, so these are the some of the rule. Now let's solve our question. Okay, a complete question I will be solving for you. Fine. So there is a, suppose let us draw ER diagram first. Okay, so I am going to draw on this page and table I will be drawing in another page. So please draw this ER diagram in your copy before solving or doing the. Okay, so we can see if I have a employee. Okay, we are just doing a relationship or ER diagram for employee who is working in a department. Okay, so there is employee who works in a department. Okay, so the relationship is many employee can work in one department. Let us draw the attribute of this, which is EID. It has also containing e-name and it also contain salary. Okay, so this employee is a what? It is a manager also. It can be a manager. Okay, so this manager has got its own ID, it has got its own name, it has got its own phone number. Okay, so this manager, it manages. Okay, the relationship name is manages. It manages a department. So one manager can manage one department. Okay, now for the department part, we have got another attribute, that is department ID, department name and department address. Okay, so the next attribute can be here if you have a relation like control. Okay, so one department can control M projects. So it has got its own ID like project ID and project name. Okay, here again another relation is a works on relation. So M employee can work on M project. Yes, and here and there is another relation which is depends on. Okay, it means that okay, so suppose if any employee has got a dependent, which is dependent will get its own name, its own age and its own gender. Okay, so this dependent depends on employee, so there can be M dependent of a single employee. Okay, so you can see this is a weak entity, this is a weak entity, this is a strong entity, this is a generalization, there is a one-to-one relationship. One-to-one relationship, do we have one-to-one? No, we have, there is a M-to-1 relationship, M-to-N relationship, one-to-M relationship. Okay, one-to-one relationship. So everything I have put here, all the attributes that we need for drawing a table I have put here. Now please draw this ER diagram in your copy, because I have already drawn this in my copy, in my notebook. Now I am going to draw the table or the relational schema form of this diagram. Okay, so please draw this in your copy because I already have this diagram. So I'm going to clear this and I'm going to draw the table now. Okay, so first of all, what we have a first table known as the employee table. So let's draw the first table. Okay, so we have an employee table which has contained its EID, its name, its salary. Okay, it has got all its attributes. Now next one is there is a attribute known as manager. Okay, so let's draw a manager. Manager has got its own ID, its own name and its own phone. But between employee and manager, this is the employee table. Let me write here. This is the employee table and this is the manager table. So if you see in the diagram, between employee and manager, there is a generalization relationship. It means that every manager is an employee. So we are going to include the EID or the employee ID in this manager table and we are going to join this like this. Now we have got another attribute, another table which is known as the project table. So project table has got its own project ID and project name. So this is a project table. Okay, so what is the relation with the project table? I think it has got relation with the department. Okay, so let's see another. We have got another table which is a department. Let me draw all the tables and then we can see the relationship between them. Okay, so department table, department has got its own ID, department has got its own name and department has got its own address. Now do we have other tables? Yes, we have got two more tables to draw. First one is works on table. Okay, works on, employee works on project. So we have got a project table, we have got a works in table. Okay, works on table, it consists two attributes. So it is a relationship, so it will contain the primary key of other tables. Okay, so it will contain two primary key, we'll see later. And then we have a last table which is called the dependent table. Okay, so dependent table, it consists its name, its age and its gender. Okay, now let me start with the first one is the manager. It can be a employee, first relation. Okay, second one is a employee works in a department. A employee works in a department, so it is going to contain the ID of this because M employee works in N department. So what I told you, if there is an M to N relationship, it is going to contain the foreign key of other table. So it will contain the foreign key of this department table. Remember, M to N, this side will contain the foreign key. So M employee can work in one department. Okay, so that is the second thing we got. Now third one is a dependent. Yes, there is a dependent and employee relationship. So a dependent, it depends on the employee. So of course this dependent is going to get the employee ID as its foreign key. Okay, the third part of this. Now next part is project. Okay, so what is the relation? What is the relation? Project and works on. So it will contain first attribute as the project ID because an employee works on a project. So we can say here employee works on a project. So there are two tables connecting this relation, employee and project. So first attribute it will get as a PID and second attribute it is going to get as the employee ID because employee works on project. Okay, so this is the next relationship. Okay, so that's all. This is the conversion of diagram into this tabular form. So due to lack of space, I think it's a bit messy, but I hope you got it, because everything that we are drawing which will contain what, that all thing we discussed in the rule portion. Okay, so if you want me to draw another relation from the diagram, please let me know, and till then stay safe and thank you.